Good evening, everybody. We are looking for a real valued solution to this exponential equation with linear exponents. Now, a couple of important facts. 3 to the 4th is equal to 81, which is the base here. You see the base 81 happening 4 times. And also another property that comes in quite handy is, I don't know what they call it, the multiply rule for exponents or something, but if you have a to the m raised to the n, that's like saying you have n copies of m copies. So that means there are m times n copies. And so really that law of exponents is nothing more than a fairly rudimentary combinatorics exercise. Now both of these facts came into play here. 81 got replaced with 3 to the 4th, and then the 4 got multiplied against the 2x to give 8x, and 4 times 7 is 28, and of course that happened 4 times. So these are the two truths that led, here's our original equation, it led to this transformation right here. Okay, now let's keep going. So I just recopied this result down here and noted that also, I did a little bit more. I set it equal to the constant, which is 2916. And this is another thing that takes a little bit of time. The 2916 is 4 times 729. It's clearly divisible by 2, and it's divisible by 3 because these digits sum up to a number that's divisible by 3. 9 plus 2 is 11, plus 1 is 12, plus 6 is 18, and 18 is divisible by 3. So the whole number is divisible by 3 as well. And so eventually you'll get to this factorization here. Now, so if we carry on here, what makes this really nice is we have 4 copies of this, right? So you can rewrite these 4 summands as 4 times one of them by the distributive property. And then you get this statement here where you can see that the 4's clearly cancel out. All right, so what we end up with down here would be 3 to the 8x plus 28. And again, that 8x plus 28 is the entire exponent, a linear function in the exponent position here. And then we have 3 to the 6th, equal to 3 to the 6th, excuse me. And again, all that happened here was the 4's conveniently canceled out, okay? Now, once we're at this stage, it's a very simple process. Some teachers and some students kind of dismiss what's really going on here and just say, oh, the 3's cancel. But the reason that the base 3 cancels is because the exponential function is a one-to-one function. If it weren't a one-to-one function, you couldn't just cancel. In fact, that's almost the definition of a one-to-one function. F at A equals F at B implies A equals B. Here our F would just be 3 raised to the X, okay? And so anyway, we can equate the exponents. We get 8x plus 28 is equal to 6. And again, we can equate these exponents because the function, the exponential function, is a one-to-one function. Let's see, where does this lead us? If we subtract 28 from both sides, we get 8x equals to negative 22. And let's see if we can handle this in our head. If you divide through by 8 and divide by 4, you get x is equal to minus 11 over 4. Minus 11 divided by 4 is the solution, folks. And you could I'm not going to check it. We didn't do anything wrong. Some people like to check. I don't think it's really necessary here. But it's a fairly straightforward check, I believe, if you go back to the original question. So that's the solution, folks. And again, not a particularly difficult problem. You had to rewrite the left-hand side in terms of base 3, and then root for a power of 3 being present as a factor in 2916, which it was right here. 729 is 3 to the 6th power, I think, isn't it? Yeah, 3 to the 5th is 243. Yeah, I got that right. Okay, just want to double check. But anyway, that's the solution. X is equal to minus 11 fourths. Thanks for viewing.